So we saw a graph on 3 nodes, right? I would like to see if this process can be better understood by writing it as a matrix operation. So that's my motive. This process is a matrix multiplication, and we'll see how exactly can one see this as matrix multiplication. Good. So now let me try writing a 3 cross 3 matrix like this. You will soon understand what is the motivation behind writing it as a matrix, but please bear with me. As of now, try to see what I'm trying to do here. Okay, it's a pretty straightforward process. So I'll write down a matrix like this, and then I'll write down 1 by 3, 1 by 3, 1 by 3. And that's how we start. That's where we start from. As you can see, it's 1 by 3 here, 1 by 3 here, and 1 by 3 here. Correct? Okay. So we start as 1 by 3, 1 by 3, 1 by 3, and what I need is the next vector, whatever I'm going to get. And what is that? As you all know, the value of A, B, C will respectively be so much. We start with C being 1 by 3 plus 1 by 6. Why is that? That's because you have this C here. C has 2 incoming edges, and from B, C gets B gives half to A and half to C, and B gets 1 by 6 from C gets 1 by 6 from B, and it gets 1 by 3 from A. Correct? Okay. Now, what next? B gets 1 by 3, right? How is that? B gets 1 by 3 from C. Everything of what C has, B gets. Good. So I'm going to write 1 by 3 here. Okay. Next. A gets 1 by 6. Why is that? That's because from B you have 2 edges going, and half is given to A and the other half is given to C, and half of 1 by 3 happens to be 1 over 6. So it's going to be 1 over 6, as you can see. Next, you observe that this converges to 1. This adds up to 1, not converges. This adds up to 1, right? And my big question right now is, what is that matrix which, when multiplied with this vector, gives rise to this vector? Okay, what is that matrix? Let us look into it. Right, so now I will write a matrix which will give me 1 by 3, 1 by 3, 1 by 3 as 1 by 6, 1 by 3, and 1 by 2. 1 by 3 plus 1 by 6, as you can see, is 1 by 2. Okay, all right. So can this process be captured as a matrix multiplication process? That's my question. All right. Yes, it can be, is what you will observe very soon. That's because this is the matrix which will give rise to this vector when you multiply this vector. And this is my matrix. You can verify it. So take a minute's pause and see how exactly this matrix is giving rise to the next iteration. Let me go through it slowly so that you all understand. So when you multiply 0, half and 0, to 1 by 3, 1 by 3 and 1 by 3, basically this half gets multiplied with this 1 by 3 giving you 0, 1 by 2 gets multiplied with 1 by 3 giving you 1 by 6, and 0 gets multiplied with 1 by 3 giving you 0, right? Okay. So as you would have observed, this is precisely the process that's happening here, correct? That is precisely the process that's happening here. So I'm just capturing it as a matrix. It's a straightforward thing. You can observe what's happening here. Take a couple of minutes and then observe it. We'll go to the next slide and we will see what has this to do with PageRank. Now, what have we done so far? For a given network, we start from 1 by 3, 1 by 3, 1 by 3 and see if it converges or not. We observe that it converges. This is the first point. The second point is that we note that these iterations that we are doing right now can be seen as matrix multiplication process. Correct? We just saw it right now. Coming next, we're going to show this next, that why does it converge? Whatever we saw in the Google spreadsheet, if you remember, it converges, right? Why exactly does it converge? What is the process here, right? And the fourth point is, what has PageRank to do with all these things? Okay, we'll see this one by one.